Hello everyone, welcome. This presentation is about EGT1 Task 2 on elasticity. My name is Wade Roberts and I will be your guide through this task. I'm a course mentor here at WGU. My PhD is in economics from the University of Utah with fields in development, labor, public health, and gender. My current research is in Cambodia. In the microfinance sector, I also deal with different poverty, inequality, and socioeconomic issues. Today, as we go through the task, we're going to have a little bit of fun, and we're going to use an acronym for ELASTIC here, specifically 11 lions and 7 tame ice crocodiles. This will help us to learn the task. We're going to start here with the 7 crocodiles. As you can see here, the little bounding ice crocodiles off to the right, they're jumping there. The first 3 are just to the right of price elasticity of demand. This is an equation, one of 3 elastic equations for this task. There are also 2 ice crocodiles for cross elasticity and another 2 for income elasticity. Essentially, what we have here is the following. Each of these measures of elasticity, when you plug in particulars to the equation, you end up getting an answer to the equation. Contingent on where that answer falls relative to a threshold, we end up naming the measure of elasticity, the categories. And in price elasticity of demand, there are 3 possible delineations or categories that can result. Elastic, inelastic, and unit elastic. These categorizations result contingent on the threshold of 1. In cross elasticity and income elasticity, the threshold is not 1, but rather 0, meaning that substitutes and complements for cross elasticity and normal and inferior for income elasticity result relative to the threshold of 0 and not 1, as is the case in price elasticity. Each of these equations is similar to the customizable equation you see here. Let's explain this and explore it a little bit. In the denominator, you'll see here that we have percent change in question mark. This delta here reflects change variable, okay? The question mark here is really where we plug in either 1, 2, or 3, which is what gives us those 3 different equations. Okay? We're looking for a relative, that's where the percent comes in, a relative change in typically a price or an income variable in number 3. Okay? This is the story start. This is where we start the story, and it's because it's the variable that we have some degree of control over. Following the control variable down here on the bottom, or the denominator, the question that economists are really looking at is, how do consumers respond? This QD up here represents quantity demand. We're still looking at a relative, that's where the percent comes from, and a change, the delta. We're looking at the percent change in quantity demand that results from a percent change in price, and then we make the numerator relative to the denominator, resulting in an answer that we will call a coefficient. Let's look at price elasticity of demand, our first equation. The storyline here could go as follows. The price of a widget may increase by 10%. A widget is nothing more than an arbitrary unit of production. In response to this price change, however, what we want to know is how the consumer demand will change following the 10% increase in the price of a widget. Again, in the equation, if a widget were to increase by 10%, economists want to know by how much quantity demand will fall. Now notice that I indicated quantity demand will fall. This follows from the precepts of the law of demand, stating that there's an inverse relationship between price and quantity demand. Said another way, when things are more expensive, we have a lower demand for those products, or we can afford less of those products. And conversely, when the price is lower, the quantity demand is higher. This gives us the classic downward sloping demand curve in a product market. For each of the equations that we are to use for this task, you should follow specific steps that are delineated here. The first step is to plug in the story particulars. This is where you introduce some specific numbers into the equation. Following which, step 2, you should compute an answer. The answer is also the coefficient. After you have computed an answer or coefficient, you are now to compare the coefficient to a critical threshold. Now, for price elasticity of demand, our first equation, the critical threshold is 1, meaning that you will always compare whatever coefficient results from price elasticity of demand to the number 1. And step 4, you will then categorize the product or service contingent on the judgment against that threshold. The possible categories that could result from price elasticity of demand are first, elastic, second, inelastic, and third, unit elastic. More specifically, anytime we find that the coefficient or answer to the price elasticity of demand equation is greater than 1, we will call this product or service elastic. Elastic means price sensitive. Anytime that price elasticity of demand equation results in something less than 1, we will call that product or service inelastic. Inelastic is weak in its price sensitivity. And the final possibility is that price elasticity of demand could result in something that is exactly and precisely equal to 1. In this case, we call this unit elastic. This would mean that unit per unit, price change is matched in quantity demand fluctuation. Unit elasticity in regards to products that are on the market is rare. Although theoretically we could land at 1, we often don't find that products do fall in the unit elastic specific delineation. Critical components to price elasticity of demand are as follows. Number 1, the threshold again is set at 1. Number 2, there are no negative numbers. Now, the reason why this works is the following. Economists believe in the law of demand, which states that when the price goes up, quantity demand goes down. If quantity demand goes down, that would give this a negative number, which would consequently result in a coefficient or answer that was also negative. Economists know and believe wholeheartedly in the law of demand. Accordingly, the negative sign is not interesting to economists. What is interesting, rather, is the degree to which quantity demand fluctuates. Accordingly, you will never end up with a negative number because we take the absolute value of any coefficient that results from the price elasticity of demand equation. Categories of elasticity only. This means that we're only looking at whether or not a product is elastic, inelastic, or unit elastic. In regards to elasticity, we are not asking the question of what degree of elasticity is accomplished. For example, if we have a situation in which price elasticity of demand results in a coefficient of 1.5, categorically we place this product into the same bin as we would if the price elasticity of demand equation were to result in a coefficient of 100. Anything greater than 1 is categorically placed into this bin that we're calling elastic. Similarly, with inelastic, anything less than 1, but bounded by 0 because we take absolute values, is called inelastic. We do not concern ourselves with the degree of inelastic. or degree of elasticity within the inelastic category. While this is something economists look at, this is beyond the scope of this task. Let's look at 3 examples. Suppose the price of bread were to increase by 10%. Note that the story is starting in the denominator, or the bottom of the equation. What is sought from this is in the numerator, or top of the equation. How do consumers respond? Respond to what? Well, how do they respond to the price increase of bread? It is important that we distinguish which product or service we're talking about here, because the whole point of this equation is to understand consumer response to price change of specific products. Nationwide averages show that following a 10% increase in the price of bread, consumers respond by purchasing 1.5% less bread. Accordingly, we can follow these 4 steps, again in this box. In going from the beginning of the story all the way to the end, we start with the theoretic construct of the equation. We plug in the story particulars. Where do these come from? Well, I just gave you the storyline. The 10% increase in the price of bread goes in the denominator. This is the percent change in the price of bread in this case. The other story particular is also given to you. You're not expected to find out what consumers are doing in their response. This is in the numerator, and this would always be given to you at this level. So this is the 1.5% that we plug in at the top. And as you can see, that mathematically this works out to 0.15, which is something less than 1, and accordingly, we categorically call bread an inelastic product, meaning not price sensitive. Let's look at example number 2. Suppose the price of National Geographic World Maps increases by 10%. Now you may notice that I'm using 10%, and you may wonder, does it always have to increase by 10%? Well, no, it doesn't. But it makes math simple. People think in deciles, and it's easy to divide by 10. So you can use whatever number you would like, but in these examples, I like to keep things simple. Following the price increase of the National Geographic World Maps, we again ask the question, how do consumers respond? Well, again, we start the story in the denominator, and we ask a question about consumer behavior in the numerator. Nationwide statistics reveal that consumers vote with their feet and purchase 19.3% less of those products. Accordingly, in following the steps, we've plugged in the story particulars, a 10% increase in the price of maps in the bottom, followed by consumer response of 19.3% reduction in quantity purchased, resulting in a coefficient or answer of 1.93. Judging 1.93 against the critical threshold of 1 results in an elastic answer, meaning the National Geographic World Maps are price sensitive. If you increase the price by 10%, you should expect as a producer nearly a 20% reduction in sales. Example number 3. Suppose the price of a Toyota Camry, a car, increases by also 10%. How do consumers respond? Hopefully by this point you're seeing the pattern of having some sort of price change, asking how consumers respond. And then here in the next slide, following these basic steps of plug and play, here we plugged in the story particulars and computed an answer. When the price of Toyota Camrys goes up by 10%, in this example, we're supposing that the demand also falls by 10%. That's a made-up figure, by the way. The other two are actual. This is one you kind of have to invent because it's very difficult to find anything close to this. So because we end up with a number that is exactly equal to 1, we then call this product unit elastic. Here are some examples that are provided in the McConnell text. The coefficients here in yellow are all less than 1 and therefore inelastic. categorically placed in the same bin. And the products here, these coefficients that are in purple, are elastic with a coefficient greater than 1. The way that an economist would interpret these numbers is as follows. Suppose we want to know consumer response and projecting forward in regards to fresh peas. We know the history, and part of projecting a plan forward is typically based on past performance. It doesn't guarantee anything, there is a degree of uncertainty there, but it's typically the best thing we have to go off of, and producers use that very heavily. However, we know as a producer that if we increase the price of fresh peas by 10%, that there will be a 28.3% reduction in sales, just by moving the decimal 1 point. Whereas here, with eggs, we'll say, we can raise the price of eggs by 10% and only have a 3.2% reduction in sales. This helps us when we are going about our profit maximizing behavior as producers and business owners. We've now captured 3 of our ice crocodiles. We've got the other 2 cages situated and ready to go. And now we can start working on the other 2 equations. We've developed a framework already, so this will go a little quicker now. Cross-price elasticity looks a little more complex with the length of the equation here, but it's rather quite simple and very similar to what we did in the last. Here we start with the percent change in the price of a good. We're going to call it good X though, because we're going to distinguish now on the top with a different good. Here we're going to ask not how much less of good X are people going to buy in response to the price increase, but rather, does the price increase here impact in any way other goods? What other goods? Well, any other goods, that's the question. So when you see big capital E here for elasticity and the XY is indicative of the 2 different products or cross-price elasticity. Don't confuse the XY with chromosomes. Here we'll get our 4th and our 5th ice crocodile. As we'll see, we're looking at the price of another good, and the categories, the possible answers resulting from this equation when we plug in the particulars are either substitutes or complements. More specifically, if the coefficient results in something greater than 0, we will call the good a substitute good. However, if the coefficient is less than 0, we call the good complement. This also goes for services as well. The critical components of cross-price elasticity are as follows. The threshold is now 0. Please remember that when we were looking at our first equation, our threshold was 1. Now our threshold is 0. This means that we're looking at a positive-negative distinction. We just want to know whether or not products are related. Again, the degree to which they are related is beyond the scope of this task. We simply detail whether or not they are related and leave it be. We should also recognize that we can end up with a 0. However, if the price of good X increases and it does not impact in any way the demand for good Y, which would result in a coefficient of 0. This is not interesting to economists, this independent relationship between prices and goods. For example, let's use 2 of the products we've already discussed. Suppose the price of bread increases 10%. What would happen to the demand for National Geographic maps in response to that price shock? Probably nothing. And because of that, we would end up with a 0, meaning those 2 products are not related. Let's look at 2 examples. First, let's suppose that the price of steak, meat, beef, increases by 10%. The question that we're going to ask here is, how does this influence the demand for chicken? So chicken becomes good Y up here. The answer is that demand for chicken increases by 4.2%. Let's go through the steps. First, we start with our theoretic equation here, to which we can apply story particulars. In this case, we have steak increasing by 10% in the denominator, starting the story the same as always. But we find in response to this price increase that when people show up at the store on task or assignment to acquire beef for their cookout, they see the price of steak and then they keep walking. They walk a couple more steps down the meat aisle and find chicken instead, meaning that they are substituting steak for chicken. Okay? We know this. We know that there's substitutes in consumption simply because the coefficient is positive. The degree to which it's positive does indicate its strength, but again, we're just putting everything into a bin. As long as this number is anything greater than 0, it can be 0.0001 or it can be 100 or 200. It's still categorically called a substitute good. Example number 2. I'm going to start the story the same, not only the same in regards to the 10% increase in price, but also in regards to steak as a product. This will help us to explain this and examine this more thoroughly. Now the question that we're going to ask in regards to good Y, though, doesn't have anything to do with chicken. Rather, we're going to relate it to a steak sauce. A1, which is the best steak sauce out there. For those of you who haven't tried it, I highly endorse it. How is the demand for A1 steak sauce influenced? The answer is, in response to a 10% increase in steak, we find that the demand for A1 steak sauce decreases by 9%. Most people are primarily using it for steak, as you can see. 9%. This is a very strong correlation. Again, we plug in the story particulars, as you can see here, which results in, now notice we're not taking the absolute value anymore as we did in the first equation. Here we leave that negative sign. In fact, that negative sign means everything because it ends up giving us a negative number indicating that these goods are complements, meaning that they're consumed together. Another example might be hot dogs and hot dog buns. If you go to buy a hot dog and you find the price of hot dogs goes up, not only are you less likely to buy hot dogs, but you're also going to find that your demand for hot dog buns falls as well, meaning that these goods go together. That's what a complement good is. Now we've captured 2 more of our ice crocodiles for substitutes and complements. Let's take a look at our third equation, income elasticity. A brief explanation here is required, specifically because the denominator has changed in nature slightly, instead of looking at the percent change in price. This is still a type of price, but it's more specific. It's an income. It's a personal income of an individual. And we're now looking at how your income change is going to influence your demand for various products. The overarching question that's being asked here is the following. If your income were to go up, would you want more or less of a specific good? We find that most goods we want more of. Somewhere between 82 and 85% of the consumer goods in the United States market, domestic market, are considered to be normal. However, the remaining percentage are considered inferior, meaning that if we were to experience an income increase, we would actually consume those goods less. The income categories that result from income elasticity are normal goods and inferior goods. Normal is also called superior by many economic authors, including the McConnell authors. If income elasticity equation results in a coefficient or answer that is greater than 0, we call this good or service normal. If, however, the coefficient for income elasticity results in a number less than 0, or a negative number, we call this good or service inferior. Critical components of income elasticity are as follows. The threshold is again 0, meaning that we're making a positive or negative distinction. Notice here that we don't talk about goods falling at 0 because we don't find that to be a possibility. Let's look at a couple of examples. Suppose your income goes up by 10%. How does this influence your demand for a sports car? Now, you can think about this on an individual level. You can also think about it on an aggregate level, meaning when you combine all of the individuals together and take their average behavior, what does the typical person's demand do in this situation? Well, we find that the demand for the Audi A1, the sports car, increases by 1%, following a 10% increase in income. When we plug in these particulars here to this equation, we find that we end up with a positive number. Again, how positive it is not the point of this task. The degree is not the point. The category is. And if this is anything positive, then categorically we call the good normal, meaning that our income going up would be related with a positive demand for the product. You can certainly reverse those statements as well. I find it easier to always ask it in a positive direction in the denominator here because it confuses students less. Let's look at a second example. Let's start again by supposing that your income increases by 10%. How is your demand for Geo Metro impacted? Now, I can speak to this because I drove a Geo Metro for several years. The answer is that the demand for Geo Metro decreases or falls by 3%. That gives us, when we plug in these story particulars, a negative sign here, which is very telling, very important, because anytime you get any negative sign here at all, this tells us our coefficient will be negative, and the good will therefore be inferior. There we have it. We now have 7 ice crocodiles caged and the concepts understood. Let's move on to the remainder of the task. We need to tame the ice crocodiles. In taming the ice crocodiles, we're going to start with the T. Time. Consumers' time horizon needs to be understood, specifically in regards to elasticity. Consumer time horizon needs to be understood specifically in reference to elasticity. Consider the length of time that the consumer has to make an alternative choice. Ultimately, the conclusion is that the demand will be more elastic for longer periods of time. The long run versus the short run is classically defined at the year mark. For this task, it's not critical that that is done. Rather, we're saying now versus later. How do consumers respond? How is the consumer time horizon a relevant issue? Let's look at an example. Let's suppose that you wake up tomorrow morning and you're headed out of the door a little late, a tad tardy, and you realize on your way to work that your gas tank is empty. You're not going to make it. Accordingly, even though you're going to be late for work, you pull over into a gas station. And just prior to starting to fill it up, you realize that the price for the cheapest option is $7 a gallon. Quickly placing your geography and realizing that you are not in Europe, you realize this is a very high price. So what do? Well, today you probably put gas in your tank. Tomorrow, or next week, or next year, you may change your arrangement. You may carpool or take the bus, your bike. You may find another option. In fact, next year you could even move closer to your job or change jobs. Meaning that price sensitivity, which is elasticity, is distinctly different in the short run versus the long run because of options. When economists look at and measure consumer response to gasoline increases, which we have many examples to pull from in the literature now, this has happened almost consistently the last 30 years. This is what's found. In the short run, and this is classically defined in this statement at the year mark, in the short run, this SR here, we find that with a 10% increase in the price of gas, consumer demand falls by 2%. Now, in our elasticity of demand equation, that would give us a 2 on top, a 10 on bottom. That's certainly inelastic. It's less than 1. However, in the long run, we find that consumer demand falls by 6%. 6 is still less than 10. It's still inelastic, but it's 3 times as strong as it was in the short run because consumers have more options. Let's take a look at the A. A standing for availability of substitutes. Demand is more elastic when another product can easily be purchased to replace the original product. Let's look at an example. We'll combine these two right here. Let's say that you are headed to the grocery store on task or assignment to acquire 2 things, apples and eggs. As you get to where the apples are located, you notice that the price of apples has increased dramatically. They're way higher than you expected. So your mind quickly thinks, is it worth it? As it's thinking about this, it's also thinking, is there anything else that I can get? You may walk past the Fiji apples and you may look for different types. You may see if there's something else that for some reason didn't increase. Maybe the Gala apples didn't go up and you may get those instead. But if all apples are more expensive, you might just buy an orange. However, when you arrive at the eggs and notice that they have also increased in price, as your mind tries to detail and figure out a way around it, you quickly realize that there are no close substitutes for eggs. So, accordingly, your demand behavior is determined, meaning that you are more likely to pay the higher price for eggs simply because there's not another option. So the availability of substitutes is a key principle when you're thinking about demand for products. Look at the M. Specifically, I've put here as a very important tagline at the beginning, monthly, okay? Because the example you need to give needs to be a monthly example. Proportion of income. Another word that can be used in place of proportion is share. In regards to the proportion of consumer income, this principle is asking something very important. I do want to point something out here. This is one of the points that's often misunderstood by students, and I believe it's because of the word income. Oftentimes when students see the word income here, I believe that their mind quickly remembers income elasticity. This is a different principle entirely. Income elasticity was asking, if your income goes up, do you want more or less of a good? This question is something completely different. More specifically, consider this. Consider we have an individual named Susie. Susie here, as you can see, is brushing her teeth vigorously. Every month, Susie purchases a new toothbrush for $2. She also pays her rent for $2,000. Those are the only 2 products that Susie consumes in this example to keep things simple. I also want to point out that the $2 for her toothbrush represents a small share or proportion of her income, whereas the $2,000 that she pays for rent represents a large share of her income. Now, let's suppose that in a specific month, the price of both the toothbrush and rent increase by 50%, so both of them become more expensive to the same degree. Now, how does Susie respond? Well, it's likely that Susie shows up at the store to buy her new toothbrush for $2, notices that with a 50% increase, this has rendered the price of a toothbrush now $3. She may notice, she may not. Either way, she's very likely to still buy the toothbrush because the price change came to a product that represents a small share of her income. Now, in regards to rent, even though it went up by the same percent, 50%, which renders it now at $3,000 instead of $2,000, it's very unlikely that Susie will be able to pay for rent because the price shock came within the constraint of a product that represents a large or larger share of her income. What does this all mean? When consumers are making their purchasing decisions, they make them partly based on the price of the product relative to their income. It's a relative measure. And specifically, their response is going to be more elastic or price sensitive for a good that represents a large share of income. Think about the last time you went out to eat. It's likely that if you're like most Americans, you ordered a Coke or a Pepsi, knowing full well that as they brought that out and poured it over some ice in a glass, you'd be paying $1.50. You could walk across the street and purchase the same product for 50 cents. Now, arguably, it may not be the same with the service. However, you're paying 300% markup for a good. The only reason we're willing to do that is because that 50 cents to $1.50, either way, represents a small share of our income. We wouldn't be able to absorb, nor willing to pay, a 300% markup, say, on the mortgage for our home or our car payment. That's the point of proportion of income principle. Now to the E of taming these ice crocodiles. Elasticity ranges. This is historically the most missed element of Task 2 by students, most misunderstood. I want to point you first to figure 4.3 in the McConnell text. This is where this specifically comes from. Now, when you do your task element related to this, element G, you are not to use figure 4.3 from the McConnell text. Rather, you are to use an uploaded document from TaskStream. The charts are similar, but the axes variables are different. So it's critical that you pay attention to that detail. Now, let's walk through this storyline here. First of all, your ultimate job is to tell the grader, the evaluator, that you understand what ranges of this demand curve right here, this green line, are elastic, unit elastic, and inelastic. Okay? Now, as you can see here, the answers are kind of detailed already for you, but we need to understand where they come from so that you can apply this to the one that you will be uploading in TaskStream. So, first of all, well, let's start here. First, it's critical to understand that these two diagrams are related. More specifically, this demand curve is where the information is coming from in order to create this. Okay? So everything that you see here ultimately comes from the demand curve. The demand curve, though, isn't just plopped right there. This actually comes from a specific storyline logic as well. Let me be more precise and more specific. Let's say that you and I create a product together that we want to take to market in an effort to retire early. We don't know exactly how to go about pricing the product. Let's say that there's no comparables. There's nothing in the marketplace that's exactly like it. Let's start by pricing it at $8 and see what happens. We wait a period of time and we notice that 1,000, as you can see down here, 1,000 of our product was sold when it was priced at $8. Now, is that the optimal price? Well, we don't know yet. Let's see. Let's start by moving this direction. So for the next month, we drop the price to 7 and we see what happens. After that month passes, we see that 2 of them sold. 2,000 rather. Now, that's where point A and B come from. That's how the demand curve is actually structured, is by looking at how consumers respond in demand to price change. Okay? Now, between A and B, that's a segment of the demand curve. Okay? Between A and B, this is an elastic portion of the demand curve. How do we know? Well, there's a couple ways of knowing. You can either do the math or you can use the total revenue test. Now let's go through both. In order to do the math, you're going to use that first equation that we used, elasticity of demand. So you can look at the percent change in price. Now, this is a percent change, not an absolute. So from 8 to 7, okay? I realize that's, so, you know, if it was 80 cents, it'd be 7.20. Let's say it's just a 10% change here to keep our numbers simple. 10% reduction in price leads to a doubling in quantity demand. That means that we end up getting a 10 on the bottom and a 100 on the top. When we divide 10 into 100, we get a number about 10. And while this isn't completely 10%, it certainly works out to be a number greater than 1. And the only thing we have to have in order for it to be an elastic portion is the coefficient greater than 1. Okay? So, the other way we can do this is as follows. The total revenue test. You don't really actually have to work out the math. All you need to do is compare what happens to total revenue. Because we know by law that the elastic demand portion is anywhere where price is going down and total revenue is also going up. That means at point A, where quantity demand is 1 and price is 8, we can multiply those together. Price times quantity equals total revenue. So 8 times 1 equals 8. That gives us our first point over here on the total revenue curve. When we dropped the price to 7, 7 multiplied by 2, price times quantity, is 14. We now can plot 14 out here on quantity of 2. Okay? Now, as you can see here, when we dropped the price, total revenue went up. Why? Well, because it's an elastic portion, meaning that the percent change in the drop of price was much more than matched in quantity demand response. And anytime that happens, we find that total revenue will go up. Now, this continues beyond point B to point C and then point D. Okay? Now, let's talk about for a minute how to state a range. First of all, a range has 2 points. And the elastic range of the demand curve is between A and D. But you don't state it between A and D. You actually have to state it in regards to the variables on the axes. So I could say something like the following. The elastic portion of the demand curve is where price is between $8 and $5, and correspondingly quantity demand is between 1 and 4. That covers elastic, and that's the framework. That's the way in which you can structure an answer about where the elastic portion of a demand curve is. You just have to calculate where it actually begins and where it ends. Now, let's talk about unit elastic. Remember, unit elastic is where we have a coefficient of 1 in regards to the elasticity of demand equation. That means that unit per unit, we find a matching of quantity demand response to price change. That means that between 5 and 4, the percent change in price here is exactly matched when we move from 4 to 5 using the midpoint method. Now over here, we find that in that same range where quantity demand is between 4 and 5, total revenue is unchanged at 20. According to the total revenue test, the unit elastic demand is where price goes down, but the total revenue stays the same. Okay? So, between 5 and 4, our total revenue is unchanged. Accordingly, that is the range between 5 and 4 and between 4 and 5, where the demand curve is unit elastic. Now notice that we used 5 here, indicating point D. We used it twice. We used it as the lower bound for the elastic range, but we also used it as the upper bound for the unit elastic range. That is completely appropriate. Now, finally, we have the inelastic range. Here we find that the coefficient for the elasticity of demand equation would be less than 1. Accordingly, with the total revenue test, we find that the inelastic demand is anywhere where price is going down and the same direction down is followed in total revenue. So you can see that the total revenue is going down here at the same time as price is falling from 4 down to 1. Now, again, in stating the inelastic portion of the demand curve, we could say something like the following. The inelastic portion of the demand curve is where price is between 4 and 1, and correspondingly, quantity demand is between 5 and 8. On to the 11 lions. I'm not lying, here are the facts. I've chosen to use an acronym here of 411 in order to get across some of the major points about elasticity and about this task. First, E. Elasticity measures relative responsiveness to price changes. This is a reminder because some students try to do it in an absolute sense, meaning that if the price changed from 8 to 7, they say that the change was $1, instead of using a percent or a relative marker. Please use percentages. The L, largely missed. Many students struggle with the proportion of income devoted to a good, which is element E and E1 of the task. Remember not to confuse this with income elasticity. More specifically, income elasticity was the equation that was looking at how consumers responded in regards to their demand for a good following an income change. This is where we ended up delineating goods as being either normal or inferior. In regards to proportion of income devoted to a good, this is where we use the example of comparing a toothbrush and rent, and Susie was much more likely to still buy the toothbrush after it experienced a 50% increase in price, whereas rent, experiencing the same 50% increase, she was no longer able to afford, meaning that her demand response was more elastic for the good that represented a larger proportion of her income. Please do not confuse those points. The second E, examples. Examples help to illustrate your understanding. As you work through the task, remember to use examples in order to illustrate your point. It also helps if you make the examples something that relates to your life specifically. This helps to keep your Turnitin score low, as it's more likely to not match with other students. The V, very often missed. This is the most missed element of Task 2, specifically element G and G1. This is where we referenced figure 4.3 in the McConnell text. Again, a reminder, you do not use figure 4.3 when completing the task, but rather upload an attached file in TaskStream. The last E, remember to engage with the Think Well videos in your course of study for any further clarity. And finally, N, never say never. Students can learn elasticity. Watch this as many times as you need to. We also have live webinars that are very instructional and helpful, where students can ask questions or chat and get feedback specifically about their concerns. And finally, we did say that these were ice crocodiles. And so, ice in case of emergency. Number 1, please make use of the task guide, which you can find in the community pages, along with all of these other resources. We update the schedules for live webinars monthly. And anything else that's updated will be there as well. Number 2, view the instructional Think Well videos on elasticity. These are found in your course of study, and they are also referenced in the task guide. And finally, if you've done all of these things and you still have questions or are in need of additional assistance, feel free to have your student mentor set an appointment up with a course mentor, either Kathleen or Wade. I hope you've enjoyed the presentation of EGT1 Task 2. Happy studies from the economic team at WGU. Goodbye.